Hello friends, welcome to my channel. So in this session we are going to learn what is NDFA and its representation, right? So the full form of NDFA is a non-deterministic finite state of machine or non-deterministic finite automation. So just check it out in this case. In this case we are having three different state, that is Q0, Q1 and Q2. So Q0 is the initial state, right? So because the arrow pointing towards it, and q1 is the another state and q2 is the final state, right? Because it consists of two different concentric bubble. So automation starts with the initial state, say q0. If we put q0 to 0, it jumps to the same state. If we put q0 to 0, it again changes the state, that is q1. If we put q1 to 1, it is again coming back to the same state, right? That is q1. And if we put q1 to 1, it again moves to the next state or the final state, that is q2, right? So q2 in this case is the final state. That means, so based on the inputs, one particular input, that is 0, machine cannot determine which state it will process, either by q0 or either by q1. So what do you mean by NDFA? NDFA means, as it is a finite automation, that's why it is having initial state and the final state. So NDFA means based on the inputs, machine cannot determine which state it will process. So this kind of phenomena. In this case, we are having q0. If we put q0 to 0, it jumps to the same state, that is q0. If we put q0 to 0, it changes its state, that is q1. That means based on the inputs, machine cannot determine which state it will process, either by q0 or either by q1. So this kind of phenomena is known as NDFA. In this case, as I have written, just check it out. If we put q0 to 0, we are having more than one state, that is q0. That means more than two outputs, that is q0 and q1. So in this case, we are having, if we put q1 to 1, it jumps to the same state, that is q1, and changes its state, that is the final state, that is the q2, right? So this particular representation can be, we are using five different, it can be represented using five different tuple, right? Q, sigma, delta, q0 and f. Q is the finite non-empty states, sigma is the set of inputs, delta is the transition function, q0 is the initial state, and f is the final state. Now in this case, q0 is the initial state which is belonging to q, and f is the subset of q as well. But in this case, delta is the transition function which basically maps q into sigma into twice q. Q means in this case is the states, and sigma is the inputs in this case. So power set means based on the inputs we are getting more than one outputs. That means based on one particular inputs we are having more than two outputs, that is q0 and q1. Now if you can think in some other ways, so we are having particular combination, that is xyz. So all the possible combination of xyz in a power is known as power set of q. So that's why it is known as power set. So power set of q. So delta is a transition function which is basically maps in q into sigma into twice q. Now in this case, in this particular representation, we are using one particular, it can be represented using a particular string, that is 0 1 0 0. Where we are getting this particular string? Suppose this string can be externally, we are getting this particular string 0. Let us assume in this way we are having this particular string and 0 1 0 0. So q0 in this case is the initial state, delta is the transition function, right? So as we all know, the automation starts with the initial state, say q0. So in this case, so q0 is the initial state in this case. So if we put q0 to 0, where it jumps, if we put q0 to 0, it jumps to the same state, that is q0. If we put q0 to 0, changes its state, that is q0 and q1. That's why I have written, if we put just q0 to 0, we are having more than two states, that is q0 and q1. q0 and q1. Now in this case, the rest of the string is 1 0 0. The same way we can process the rest of the string. Just check it out. Just if we can move, if we process the next string, rest of the string, right? So q0 to 1, q0 to 1, just check it out. q0 to 1, q0 to 1, we are having, just we are moving to the final state, that is q2. Now the rest of the string is q1, rest of the string is 1 0 0. That's why I have written 0 0. So q1 is left. Again we can process q1 to 0, q1 to 0. No processing is there. So See, in this case, q0 to 1, q0 to 1 means, just check it out, q0 to 1, q0 to 1 means we are having q2, we are having q2. If we in q1 to 1, q1 to 1 means we are having q1 and q2, q1 and q2, q1 and q2, and rest of the string is 0 and 0, right? So again, in this case, q2, q1, q2, 0, 0. So in this case, q2 appears more than once, q2 appears more than once. This is q2 and this is again q2. That's why we are discarding one particular q2 over here. That's why finally we are writing only one q2, that is q2, q1 and 0, 0. Rest of the string is 0 and 0. Now this 0 can be processed, this particular 0 can be processed, this particular 0 can be processed. Then so q2 to, why requirement q2 to 0, just check it out. If you put q2 to 0, so no more processing is there, so that's why we are just keeping q2 as it is. q1 to 0, q1 to 0, no more processing is there, so that's why I am leaving q1 as it is, so 0, q2, q1 and 0. Now q2 to 0, q2 to 0, so no more processing is there, that's why we are finally we are having q1 and q2. So in this way 0 1 0 0 is going to be processed, and that particular string, externally we are getting that particular string, and this particular string has been provided, processed by the particular string has been processed by this particular diagram, that is figure 3.1. So this is all about the NDFA. NDFA means non-deterministic finite automation, and delta in this case is very important. No factor in this case is the delta, which is a transition function which basically maps q into sigma into twice q. So if you want to know more about this, please subscribe my channel, right? And please share your views, right? And if you have got any queries, please ask me.